right, so after approximately 2 or so minutes away from the computer, after recording the previous segment, I actually came up with a solution to our problem of outputting our stuff. So I want to show the results first so we can kind of see that. Let's see, let's open a file, test data, plane, and so on, right? And I'm going to load some blocks here. And we can see here now that we have this output, right? So we have test, and then the white content here is literals, and the red content is match content, right? So the match copy operation. And we can see fairly immediately that there's a lot being copied, right? In fact, you can see here that more and more we are doing less literals as we move through the file. And this makes sense, right? Because there are certain things we simply haven't seen yet at all, right? And so this is effectively what we can expect in a file like this, right? When we move through it, right? So let's open this file again. I'm not resetting the content here. Let me restart the application. So we're gonna open this file, and I'm gonna load just one frame. Right, so this is now our content here. You can see package LZ4 frames, test underscore frame, etc. Right, and again, this matches our plain text file, which we have here, right? So package LZ4 frames, test underscore frame, etc. Right, when I load more here now, we can see that next shows up, right? And then we have next until here, right? This F here, we get rame is being added. And then we have a large literal section, right? And then a match here, block underscore. We add checksum equals false, we can copy from here, and so on. And here we didn't have any literals at all, and so on, right? So here we actually end up copying more and more at some point, right? So here this block is going to output a little bit of content here, block count, literals, copy, hex sum, and so on. And now suddenly we can actually copy a large section, right? Because we have equals 0, and then 1 starts here, but now here it sees that, yeah, I can copy pretty much all of this stuff, right? So it copies this entire chunk in one go, and so on. So I just wanted to add this to the previous video, that we can in fact do this, and the way I did this here was this. So for every write we have, this is the same structure as before. We have this literal C string and so on, but what we actually do, we can actually remove these. We go through for every line in our write literals, right? In the literals of a thing. For every line, we say output some text, right? And this is not colored text at all. And then we say same line, because here we can't be sure that we have a new line at all. So we say for every line then in our match, right? We want to output colored text instead, right? And then we say same line, because again, we don't know if something is going to be on the same line or not, and so on. So this is how we can actually work with this. And I'm sure here actually that we could maybe use same line EX in order to not move at all, maybe. Let's try 0, 0 here. I'm gonna try this and see if we can actually get, because we do have some spaces in between things in our current version, and I want to see if we can get rid of those. And in fact, this works beautifully, right? Now we can definitely see that this is now making a lot of sense. We don't have spaces where we shouldn't have them and so on at all. So yeah, now we cut off this and we actually just have this and so on. And yeah, so I wanted to show this as a solution to this problem, because we can of course kind of colorize sections like this just by having multiple text calls and just sort of using the same line in a reasonable way if we do want to and so on. So yeah, that's it for now, and ciao, and have a nice day, and ciao. Not in that order, yeah.